yapacak galiba. Hüseyin Ali Aker vardı.
Hüseyin hocam
Ben-
yapacaksa Hüseyin hocam bilir Bartu sanırım pazartesiden.
Evet hemen
Efendim?
yapacağım.
Tamam.
Bir tek soyadını karıştırabilirim.
Özcan.
Tamam.
Okay, shall we go on?
Merhaba
Today,
hocam.
efendim, yes please.
Sorry, I just added to myself. Thank you very much. Okay, that's fine.
Okay, shall we go on? Today, I'm going to present you the regression analysis, simple and multiple regression, but I'm not going to put the application. Application I will do on the eView next week, and then after then you will do, okay? You will exercise online and I will see and evaluate you, okay? And then we will go on, because if you are exercising and learning on eView and you learn the regression analysis, ordinary list, it will be helpful for you for applying the other panel data analysis, vector error, ARDL, other will be maybe for you much better, easier, okay? If you have any question, you will interrupt me or you just let me to present and we will discuss it after then. I'm going to share the file. It is a little bit longer. It is around 100 pages. I know it is too long. Either I will divide it in two, then we do the first part today and the second part next week. I don't know if I am going to be able to present today all. Do you have any question or any suggestion? Okay. Okay. I have to get my pointer. Sorry, let me. Do you have any question?
Hocam başlamadan bir şey sorabilir miyim?
Yes, please.
Bu sunuyu şeye atacak mısınız, sayfanıza indirelim biz bunu?
Bu şimdi şeydir. Video olarak da zaten will be uploaded on the system, so you can watch it. Or if not, then I will, because if it is on the Microsoft Teams, then it is sometimes required permission. I will also upload to the YouTube. I have one, let's say, class or lecture pages. Then I will upload there. Also, you can watch also there. If not, if you are not able to watch this, okay, no problem. I will add you to the system, or you can watch on the YouTube also, where the classes or the courses in there. Okay, let's go to the regression today. I think it's not working. The battery is out. Evet. Do you have any information about the regression? Because I was planning to introduce you the classical version of course, it is difficult when we are online, but I was planning to introduce you the classical version and explaining you more comprehensively why it is used, this regression analysis in economics, or why it is important for estimating the data in regression, because it is, as you are understanding, something prognosed and determined and give you some chance to evaluate the past and plan the future. The learning objectives here is the linear multiple regression. Also, simple regression will be introduced to you, and interpret the linear multiple regression, which is in the following lessons, not now, in the review. And I will explain this multiple collinearity and describe the types of multiple regression models. The regression modeling steps: first, you are going to define the problem and the question. You specify the model, collect data. You describe data analysis, the estimate unknown parameters, and evaluate the model. And we are using all for this model to the prediction, as I said to you, for some parameters, impact of the independent variables on the dependent. Explanatory is going to be affected or is affecting the dependent variable will be introduced to you. And then also interpret the results. This is also most important part, especially for the business and economic students, because we are not mathematic professor, we are not mathematic, I think, experts. You are going to be in the business, isn't it? You are all in business. Am I right?
I think so, yes.
Evet.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. We have here simple and multiple regression simply given to you. When it is simple, we have one variable, so so-called one independent, one dependent, and the beta represents the unit change in the dependent, so-called output that is in the equation per unit change in X, which is going to affect and change the output or the production. And in simple does not take into account any other variable besides single independent variables. This is the most important part of the simple and multiple regression. Of course, the application somehow is similar, but there are some other important things that you have to know before going through. And the beta 1 or I represents the unit change in Y, so-called the dependent per unit change in X. The multiple variables taken here into account, and the effects on the dependent is going to be questioned. The assumptions in the regression analysis is the linearity, which is the Y variable is linearly related to the value of the X variables, and independency of the error. The error residual is independent for each value of X, and homoscedasticity, the variation around the line of regression be constant for all values of X, and the normality. These are the tests that you have to do together with the regression analysis. And the normality, the values of Y be normally distributed at each value of X, that you will exercise in the following slides. Why it is important and what is the importance of these assumptions in the regression analysis will be introduced to you, and then you will understand how you are going to proceed this test, or sorry, method. The regression to be performed with hypothesis, which is the null hypothesis, is supposed to be epsilon is equal to 0 and yt becomes non-stationary, and h1, which is the alternative, is supposed to be significant. All variables must become significant at level when you are going to proceed the regression analysis. So you are going to use the I0, not I1. If any variable is in I1, then you cannot proceed the regression analysis. This is the important part, because regression analysis is usually done when the variables become stationary or significant at level. You are understand, you know, I think these things. or if you don't know, then you have to take care of this, because every test before going to be proceed must be controlled and evaluated regarding to this significance. And if it is in I1 or in I0, which is in the level, then it is required to do the different test. This is done by the unit root analysis that we are going to exercise after 1 or 2 weeks later. This unit root, which is augmented DG Fuller, Philip Perron, and some other tests will be introduced to you and will be applied to being able to determine the test. And for residual, the null hypothesis is supposed to be 0. The residuals are not serially correlated, and the of course, heteroscedasticity and the normality is supposed to be realized, and H1 or the alternative is the residuals are serially correlated. Heteroscedasticity and the not normally distributed is supposed to be realized, which is the case for the regression analysis. The best regression model for being able to perform required the following qualifications or following results. First, as I said to you, the residuals are not normally correlated for the null, and for the alternative, residuals are supposed to be serially correlated. And when you are going to perform the regression analysis, it is required to get the R-square value at higher level must be at least 60% or higher for being able to reliable model, for creating a reliable model and results. And no serial correlation is supposed to be desired, and LM test will be performed, and the probability value must be higher than 0.05, which is usually done. And the heteroscedasticity in the residual p-value, so-called the probability value, must be higher than 0.05, and the residual are normally distributed, which is the histogram. So you have to employ the histogram, and the p-value must be higher than 0.05. These are the must. You have to perform this test before finalizing or before interpreting your data. Then this will then support and becomes more reliable results, because as you are understanding, when you are doing such tests or such methods or evaluations or estimations, most of the people are not considering this I1, I0 between the variables or parameters, and they are not able to take the first differentiation for being able to employ the I1 data, and then performing different, let's say, tables and results, and this will then manipulating the so-called literature. This is important, and when you are doing such mistakes, when you're performing such estimations, the journals observing that you are not qualified for this kind of estimations, then they are rejecting your paper quickly. So you have to consider these things very carefully when you are performing, and you have to interpret and give the reason why you employ this data, why you employ this test or method, and then you will then able to determine the necessary tests and methods. The sample model with hypothesis for the OLS is given here as an example. Is supposed to be real GDP is going to be affected with the manufacturing value added, retail trade, and the value added agriculture. And as you are observing here in the scenario, the hypothesis should be formulated as the HO, or so-called the null hypothesis, becomes non-stationary, and for the alternative is significant. And for the residuals is for the null. Residuals are not normal, are not serially correlated, not heteroscedastic, and normally distributed. And for the alternative, residuals are serially correlated, heteroscedastic, and not normally distributed. The goal for this OLS, so-called the ordinary least squares method, for developing a statistical model that can predict the values of a dependent as a response variable based upon the values of the independent, so-called the explanatory variables. This simple regression, when we are going to introduce to you the statistical model that utilize one quantitative independent variable x to predict the quantitative dependent variable for y. This is then the two, let's say, parameters equation will be estimated. Here is given the estimation, which we are going to use probably next week in the EView. Then the interpretation of the data will be explained to you. I'm not going to focus on this table. You will go through later, but I will explain you the impact of this, let's say, estimations. What is the importance for the economical models? Let's go through for this coefficients, standard errors, T statistics, F statistics, probability, the income, which is supposed to be here is the independent variable, and then we go through to estimate the model. Let's go how we are going to interpret the data. When we are going to the coefficients, when we look to the coefficients, which is going to be estimated for the any simplest OLS model, the coefficient science explains the direction of relative relation, between explanatory and dependent variables. So it is important. The coefficients becomes very important. This will then gives you a significant information about the impact of the parameters on the dependent and the independent, which is going to be in the process, in the model. The standard error of the coefficients indicates the accuracy of the estimated ordinary least squares coefficient with respect to its population parameter. Each standard error is the square root of the variance of the corresponding coefficient. And the t-test is a statistical hypothesis testing technique that is used to test the linearity of the relationship between the response variable and different predictor variables. In other words, it is used to determine whether or not there is a linear correlation between the response and predictor variables. The t-test helps to determine if the linear relationship is statistically significant. So t-test is also very important. It is estimated by dividing the coefficient to the standard error to becoming this t statistics. So you're going to divide the coefficient to the standard error. As you see here, when you're going to divide the coefficient to the standard error, you will get the t statistics. For the probability values must be between 0 and 0.05 to be significant model. You know this, I think. And the probability value which is above is not acceptable. The p-value for each term tests the null hypothesis that the coefficient is equal to 0 is supposed to be there is no effect. A low p-value or probability value which is less than 0.05 indicates that you can reject the null hypothesis. In other words, a predictor that has a low probability value is likely to be a meaningful addition to your model because changes in the predictor's value are related to changes in the response variable. So null hypotheses residual are not normally distributed. The R-square value explain how many percentage of Y dependent variable will be explained by the explanatory, so-called the independent variable X. The effects of independent variables on dependent variables is going to be illustrated in percentages. Of course, we are using this. Then this is also very important. And the adjusted R-square can increase or decrease the independent variable. Too many explanatory variable may cause negative signs. So we have to consider these things very important information for employing this OLS method. The F statistic, this is statistic tell how joint significant explanatory variable affect dependent variable. The higher the F value, the better the model, and the probability statistic lower the value, the better the model. It tells the statistically significance of the model. And the mean dependent variable is the average value of the dependent variable. Akaike info criteria, Schwarz info criteria, and Hanna-Quinn criteria are used to choose the best model. The lower the value, the better the model. As you are observing in the model, when we are going back to the model, you see the Akaike info criterion is the lowest one. So we gonna use this Akaike info criteria and employ this for our model. You are able to follow, I think, isn't it? I don't know if it is faster, but it is too long, and we have to go a little bit faster. And Durbin-Watson stats, yes, please. You have anything to ask? Durbin-Watson statistics tell the serial code. You have anything to ask, please? Look, okay. Durbin-Watson statistics tell the serial correlation. If the Durbin-Watson is less than 2, it is the evidence of positive serial correlation, and the model is suffering from serial correlation is, of course, not desired. So we have to consider these informations. Only from OLS table will give you a sufficient information to perform other tests. Therefore, when you are doing other tests or other methods, this OLS results is helping him to determine what to do, or to-do list will be introduced to you with this estimation. Of course, co-integration is also helping him for determining some restricted or unrestricted models, but OLS is very important. You are going to employ always this OLS for performing the other tests. Therefore, OLS must be carefully treated and learned for being able to understand and perform the other tests. The multiple regression is going to be a statistical model that utilizes 2 or more quantitative and qualitative explanatory variables, so-called X1, X2 goes to XP, to predict a quantitative dependent variable Y. And caution here, I have at least 2 variables or more is required for the multiple regression, and quantitative explanatory variables supposed to be the rule of thumb, which is in economics. In Econ 1, Econ 2, we are always explaining to students this rule of thumb, which is the important theory introduced for the random test. You know, the random walk in the macro, we are introducing regularly. This is important to know the random walk and random estimations also employed in this OLS. The multiple regression is a statistical technique that can be used to analyze the relationship between a single dependent variable and several independent variables. This objective of multiple regression analysis is to use the independent variable whose values are known to predict the value of the single dependent value. The multiple regression assumptions is going to be continued. The assumption 1 is then dependent variable is supposed to be measured on a continuous scala. It is either an interval or ratio variable, such as the estimation or performance calculation when you are in the exam from 0 to 100, or for the intelligent qualifications that is given to you between so-called 0 to 160, 180. This kind of scalas will be used in the multiple regressions for being able to perform the test. The assumption 2 suggests 2 or more independent variables, which can be either continuous, interval, or ratio variables. Categorically, ordinal or nominal variables is supposed to be introduced. For example, continuous or ordinal variables is supposed to be used. An example can be given as a group: male, female, ethnical. You can Hispanic, divide the people and determine their performance regarding to these categories. The assumption 3, you should have independency of observations, independence of the residuals. which you can easily check using the Darwin-Watson statistic. The assumption 4, there needs to be a linear relationship between the dependent variable and each of your independent variable, and B, the dependent variable and the independent variable collectively. Whilst there are a number of ways to check for these linear relationship will be introduced to you in the following chapters. And the assumption 5, your data needs to show homoscedasticity, which is where the variance along the line of best fit remains similar as you move along the line. We explain more about what this means and how to assess the homoscedasticity of your data in our enhanced multiple regression guide. Assumption 6, your data must not show multicollinearity, no relation between the data, between the variables, which occurs when you have two or more independent variables that are highly correlated with each other, which is not desired. And this leads to problem with understanding which independent variable contributes to the variance explained in the dependent variable, as well as technical issues in calculating the multiple regression model. The assumption 7, there should be a no significant outlier, high leverage points, highly influential points. As you see, we are expecting that these dots, which is the data, which is the year so-called, or the quarterly given data, must be on the line. So then we don't have any structural breaks and we don't have any problem with the estimation. This will then help you to get this collinearity and then goes to the linear estimations. Finally, you need to check that the residuals or the errors are approximately normally distributed. We explain these terms in our enhanced multiple regression, and the histogram is going to be used. And here the p-value, as I said to you, for the histogram must be higher than 0.05 for a reasonable, acceptable model. When you see, we are having here the three-dimensional illustration, and here it is given not the two-dimensional estimation and representation, but we are having now more than two variables, which is affecting and changing the y, so-called the dependent variable. Therefore, you are observing when there is some differences or some important, let's say, differences between the data, you have to determine this by employing the error term. Hypothesis here is given as at least one regression coefficient is supposed to be not equal to 0, H0, or null hypothesis suppose all the regression coefficients is 0, and the alternative is supposed to be are at least 1 is not 0. Again, alternative null hypothesis is supposed to be all coefficients is 0, and 1 in alternative must be not 0 for performing and employing. The types of the models, the positive linear relationship, the negative linear relationship, the no relationship between x and y, and positive curvilinear relationship, U-shaped curvilinear, and negative curvilinear relationship is supposed to be modeled. The multiple regression model is given here. As you are observing, you have either linear and non-linear. Linear is, as you know, is a direct straight line, and non-linear is curve, is a curve that is going to be somewhere else and affecting the other parameters. In linear, you are going to use these and performing by the linear equation, dummy variable can be employed and interaction is going to be estimated. And the nonlinear perform the polynomial square roots, the log, reciprocal, and exponentials is going to be introduced and employed in this multilinear regression. The linear model relationship between one dependent and two or more independent variable is the linear function. And as you are observing, if you go through to the x1 and exclude others, then this will be the linear equation. and the others when you are going to employ and add some other powers of x, then will be affect and change the nonlinear equation. Therefore, the equation which is given here is the dependent variable is supposed to be the y, and the rest of the x1, x2, and xp is then the independent variables. And as you see, the betas are the intercept and the coefficients of the parameters. The methods of the least square, the straight line that the best fits the data is supposed to be determined in the straight line for which the differences between the actual values y and the values that would be predicted from the fitted line of regression is so-called y hat are as small as possible. And the measures of variation explained variation sum of the squares due to regression, and unexplained variation error sum of squares, and total sum of squares then estimated. The coefficients of multiple determination is given here. As you see, it is a structurally break and increasing curve. When null hypothesis is rejected, a relationship between y and x variable is existed, and strength measured by the R squared is supposed to be estimated. The coefficients of multiple determination is the R square, and the proportion of y that is explained by the set of explanatory variables is selected. The standard error of the estimates is the standard error, the measures of the variability around the line of regression. And the interval bounds is supposed to be either upper prediction limit or upper confidence limit or lower confidence limit or lower prediction limit. As you are observing, the linear line is going to be a straight, but the upper and the lower is going to have some somehow nonlinear curves. And multiple regression equation can be represented as it is given here. And when you are going to get the coefficients, then y minus intercept then will give you the constant value, and the slope of this curve or equation then will be determined by using the b1 or beta 1, then holding the variables x2, x3, and xp fx constants. So the beta p is supposed to be the slope of the y with variable xp, holding all other variables fx constant. The mini case will be introduced to you very shortly and very quickly. To predict the consumption of the home heating oil during January from home located around Screen Lakes, two explanatory variables are selected: average daily atmosphere temperature, F Fahrenheit, and the amount of the attic isolation or insulation, which is going to be used also in Cyprus very often. Then we are going to look the case. The data is given, the consumption of the oil, the temperature, and the insulation, so-called the isolation, or the be done for the floor. Develop a model for estimating heating oil used for a single family home in the monthly of January based on average temperature and amount of insulation in inches. Is a given numbers here. We don't use this. We are not going to calculate anything. We're just going to introduce you some numbers and give you the results quickly to see how it is, because we will do this by step. Next week, maybe, I will show you how you are going to upload the data, how you're going to make, of course, quickly, I will do the unit also, and then introduce you the OLS, so-called the regression or ordinary least square method. But here we are going to make a very short, brief introduction to you. The mini case, oil is dependent and the temperature is independent here, as you are observing from this graphic. The oil is becoming affected from temperature and insulation, isn't it? Because when you change the temperature, your heating or consumption is changing depending to the temperature, and insulation is also affecting this. Therefore, we have here two independent variables, temperature and insulation, and oil is supposed to be the dependent variable which is affected from these two, isn't it? The oil is dependent and the temperature is independent. What preliminary conclusions can homeowners draw from the data? What could we are going to create a question, a crucial question for estimating this or creating a model and let's say writing a small paper or short or brief, let's say report. What could a homeowner expect heating oil consumption in gallons to be if the outside temperature is 15 Fahrenheit when the attic insulation is 10 inches thick? So depending these two given data, model is the oil. We are going to create the model now. Model is the oil, which is dependent variable. Temperature is the independent variable. Of course, we have to add here the intercept and the error term, but I didn't put here intercept this thing because this will be done later. Then the attic insulation is going to be used and estimated to see how these two parameters affecting and changing the oil consumption in a given scenario. Of course, we are adding error term if there is any structural break on the data that we are using. When we are looking here, the data, actually, there are some differences between the data, isn't it? Therefore, we have to know what is causing this consumption increase between this period. Maybe the temperature is increased during this period. As you are observing, that's probably, these are the summer periods, 63, 65, January, February, it starts to like this. Therefore, in the summer periods, we consume less oil and we don't use probably the heater. But in the winter and somehow in the autumn and in springtime, maybe we are using somehow. This is then the easiest model that we created. The multiple regression employed here, as you see, the estimated data, again, the constant insulation and temperature is estimated, standard error given, the T statistics and the p-value. As you observe, the p-value all becomes 0, which is somehow 0 to 0.05 is acceptable, and the S-square is adjusted for the given model is 95%, 98, and the standard error is 26.0.1, which is supposed to be very highly supported model for given scenario. When you put the numbers on the equation that we created, because I didn't put the intercept here, now we have the intercept here. As you are observing here, this constant is the intercept. Then we are getting this 562 as an intercept and put, and this insulation is minus 20% and the temperature is minus 5. We're gonna employ and put into the equation. As you see how we have added these all things to the equation, and we have here now some information about the, let's say, people who requested this information, and we may suggest that the temperature is affecting. When 1 unit of temperature is changing, approximately 5% of oil consumption will be increased. And when 1 unit of, let's say, isolation or insulation is realized, then 20% oil consumption will be reduced negatively. It is affected here, as you are observing, because in the model is negatively given. Therefore, it's reduce the consumption of the oil. This means when the negative signs illustrated here, you are understanding. If the numbers is positive, then it is parallelly proportional. If negative, then we have negative correlation and negative relationship. Therefore, here we are going to say that temperature and of course attic insulation positively affects when they are negative. When they reduced, then positively affect and increase the oil, or vice versa. You are understanding, I think. And the multiple regression here is going to be represent and present for a home with 0 inches of attic insulation and an outside temperature of 562.15 gallons of heating oil will be consumed in a given scenario. Quotient data boundaries and extrapolation is considered. Then the interpretation is going to be given as estimated data. Extrapolation is the process of creating new data point out of a discrete set of known data points. when we are using this given information and creating a, let's say, graphic, then interpolation is the included data and the, let's say, inclusive everything here that is affecting and changing the scenario, and an extrapolation is the outsiders which is affecting and changing the scenario, so-called. Therefore, we have to consider this kind of estimations just only for the given parameters and just only for given variables, because there are some other let's say factors affecting and changing the let's say scenario or model. And when we are creating some scenario, we have to explain the limitations, what is the impact and why it is only concentrated to this and not others, or not this country, not other countries. These things is going to be very important. And the multiple regression equation is, again, as I have given to you, is going to be interpreted. And for a home with zero attic insulation and the outside temperature of 0.562 gallons of heating oil will be consumed, I said. And for each incremental increase in degree Fahrenheit of temperature for a given amount of attic insulation, heating oil consumption drops 5.44 gallons in a given assumption. For each incremental increase in inch of attic insulation at a given temperature, heating oil consumption drops now 20%, let's say, gallons. As you see, this is somehow the effect of this scenario. For the temperature, as I said to you, the consumption of the oil is going to be reduced for 5%, and for the attic insulation, it is approximately 20% gallon oil consumption will be reduced. And this is then again supposed to be used with a numbers, which is the Fahrenheit going to be now 15, and X 10 inches is going to be used for the attic insulation, is supposed to be employed. And now we want to know what will be the impact at this given scenario when the heat or the temperature is 15 Fahrenheit and the attic thickness is 10 inches, or somehow 10 inches is used. Then the consumption, when we're going to put into the equation, will be 280.45 gallons oil consumption is supposed to be consumed in a given scenario, in a given regression analysis that we have done. Coefficients of multiple determination in such a many cases, as I said to you, the R-square value, which is very high, is the variation in heating oil, can be explained by the variation in temperature insulation. It is very high, and its effects on the temperature and the attic on oil consumption is supposed to be considerably very important. And the coefficients of multiple determinations, when we are looking to this, let's say, proportion, the variation of y explained by all x variables taken together, and the R-square value is supposed to be explained variation divided to the total variation, and the sum of squares due to regression is supposed to be divided to the total sum of squares, which is very important here again to know how we are going to interpret the R-square value. And as you are observing here, the R-square can take any value between 0 to 1, and with a value close to 1, as I mentioned to you, indicating that the greater proportion of the variance is accurate for model, which is somehow more realistic, and never decrease when new x variable is added to the model. Only y values determined with the sum of squares, total sum of squares, and disadvantages when comparing models is also must be considered and interpreted. The coefficients of multiple determination, which is adjusted, the proportion of variation in y explained by all x variables taken together, and reflects sample size, number of independent variables, smaller, more conservative than the R square, and used to compare the models. The coefficient of multiple determination, again, the R square, the proportion of the Y that is explained by the set of independent explanatory variables selected and adjusted for the number of independent variables and the sample size. And the coefficient of the multiple determination, again, for the S square, as it is 0.95% of the variation in heating oil consumption can be explained by the model adjusted for the number of independent variables and the sample size. And the coefficient of partial determination, proportion of the variation in Y explained by the variable X, holding all variables, all others constant, and must estimate separate model, and denoted for the S square in 2X variables case, the coefficient partial determination X1 with Y, holding the X2 constant, useful in selecting the X variables. Therefore, you have to consider when you are doing such estimations by excluding or including such parameters for being able to determine the impact of each variables on the dependent variables. And the coefficient of partial determination S square, the coefficient of partial variation of the variable Y with X1 holding the constant, the effects of the variables will be then X2, X3, X4 until the variables is going to be included, must be estimated. Testing overall significance show if there is a linear relationship between all X variables together and Y. Use the p-value, the hypothesis that we are creating. The HO, so-called the null hypothesis, is supposed to be the all coefficients is 0 and nonlinear relationship, and the alternative H1, at least one coefficient is not 0, at least one X variable affects Y, which is supposed to be considered. The testing model portion examines the contribution of a set of X variables to the relationship with Y. The null hypothesis, variables in set do not improve significantly. The model, when all other variables are included, must estimate separate models used in selecting X variables. And when we are going to diagnostic checking, the HO retain or reject. If reject, which is going to be rejected, p-value is supposed to be less than 0.05. The R square is adjusted. Correlation matrix is going to be employed, and the partial correlation matrix is then done. The multicollinearity, it is the occurrence of high intercorrelation among two or more independent variables in a multiple regression model, therefore is not desired. And multicollinearity is a problem. Multicollinearity is a problem because it produces regression model results that are less reliable. This is due to wider confidence interval, larger standard errors that can lower the statistical significance of the regression coefficients. I know these are too much theoretical and somehow must know things before performing the regression analysis. But this is only the knowledge. You have to know this for interpreting and performing the OLS or regression analysis better. Therefore, I am not expecting you to know all these theoretical applications and theoretical approach or the methodological guideline, but you have to know at least this for being able to interpret your data, perform your, let's say, test and estimations without problem, without mistakes, without any misleading action. We mentioned this. Multicollinearity, high correlation between X variables coefficients measure combined effects, leads to unstable coefficients depending on X variables in model. Always exists matters of degree. Example, using both total number of rooms and number of bedrooms, such as explanatory variables in same model, independent variables considered. And the examine correlation matrix, correlations between pairs of X variables are more than with Y variable. Few solutions remedies is supposed to be offered. Obtain new sample data, eliminate one correlated X variable. And evaluating multiple regression model steps, examine variation measures, do residual analysis, as I mentioned to you, test parameter significance, overall model, portions of model individual coefficients test for the multicollinearity. Multiple regression model, again, we have done this interpretation. When you are going to do the nonlinear equation or estimation, then direct you to the polynomial, square roots, log, reciprocal, and exponential application. And if it is linear, then the dummy variable linear action is employed for this estimation. The dummy variable, as you know, is going to use when there is some problem with the estimation, or when between the numbers that you are employing, the data, there are some structural breaks on the graphs that force you to use this. Then this will then good to know either you are going to use 0 or 1 for the given periods of time. Then you will employ this dummy and employ this for your model. The dummy variable regression model involves categorically X variable with 2 levels, male, female, for example, employed, not employed. And when you are going to use 0 for employed, you have to use the 1 for the not employed. Involves categorically X variable with 2 levels. And as I said to you, variables levels coded as 0 or 1. For the employed 0, then unemployed or not employed, you're going to use 1, then you will then do your test once again. Of course, you have to add to the EView, then include this dummy also into the system. Then you will then do the all estimation once again. Then this is somehow a long process. Therefore, you have to learn first this regression, simple regression I will give you. And then we will go steadily, step by step, to these applications. And then we will go to panel data. I will give you Petroni, and then vector error correction, restricted, unrestricted. These things, we are going to manage it step by step. And I will introduce you the EView applications as much as I can online. The dummy variables involves categorically X variables with 2 levels. As I said to you, female, male, employed, unemployed, and variables level coded as 0 and 1, and assumes only intercept is different and slopes are constant across categories. As you see here, the dummy variable model relationship is introduced here, male, female. Then you're gonna determine the slope. As you see, it is somehow a little bit similarly realized. And the dummy variable permits use of qualitative data, example, seasonal, class standing, location, gender differences, and you're gonna call it 1 or 0 nominative data. As part of diagnostic checking, incorporate outliers, large residuals, and influence measures is supposed to be employed. The multi-regression model, now it is the interaction. Then we are going to further employ the regression model, hypothesis interaction between pairs of X variables, response to one X variables varies at different levels of another X variable, contain two-way across product terms. Y is the dependent, is going to be B0 intercept plus B1 plus B1 multiplied with X1 variable plus, some or added to the B2 multiplied with X2 variable, plus goes like this, and then your error term then can be combined with other models and dummy variable introduced. Effects of interaction in a given scenario, as I mentioned to you, for this B1, B2, B3, and dummy. Without interaction term, effects of X1 on Y is measured by P1, beta 1. With interaction term, effects of X1 on Y is measured by the beta 1 plus beta 3 plus multiplied with X2, and effects increase as X2 increases. As you are observing, it is somehow illustrated on the graphic. When the variables which is added to this equation enlarge and increase and shift the linear curve, this is linear curve as you are observing, shift the curve upper level. This is then the interaction between the variables, which is changing the effects when we are adding some other parameters on the model. This is then the slope you are observing, changing the graphic. The multi-regression model, again, then when we are going to the nonlinear, then polynomial is done, then the square root, log, reciprocal, and exponential is further realized. The difference between linear and nonlinear regression model, the difference between linear and nonlinear regression model, as you are observing, it is not only the shape. The difference between linear and nonlinear regression model isn't as straightforward as it is sounded, as you are thinking. It is linear equation produce straight lines and nonlinear equations model curvative, but unfortunately that's not the correct interpretation. Unfortunately, a linear regression model follows a very particular form. In statistics, a regression model is linear when all terms in the model are one of the following. There is a constant parameter multiplied by an independent variable, and then you build the equation by only adding the terms together. These rules limit the form to just one type. And linear regression, then you build the equation by adding the term together. These rules limit the form to just one type. The dependent variable, constant parameters, and as you are going to, it goes like this to the equation, which is given here, y is equal to beta 0 plus beta 1 multiplied x1 plus beta 2 multiplied x2 plus goes like this, and beta n and beta x multiplied with x n or a. The regression example below model the relationship between body mass index and the body fat percentage is illustrated, and the prediction with regression analysis. How it is? It is a linear model that used a quadratic square term, the model, the curved relationship. The body mass index is on the x-axis and the fat percentages is on the y. And as you see, there is somehow a curvilinear relationship between these two is realized, and it is not all approaching to the line, but it is somehow on this line, on this direction. Then we can predict this is given scenario. I show the linear regression model have one basic configuration. Now we will focus on the non-linear. If a regression equation doesn't follow the rules for a linear model, then it must be a nonlinear. Then it is that simple. A nonlinear model is literally not linear, as I mentioned. Consequently, nonlinear regression can be fit an enormous variety of curves. However, because there are so many candidates, you may need to conduct some research to determine which functional form provides the best fit for your data. As it is illustrated here, the nonlinear regression is given here. The theta multiplied with x, 0, theta to 2. Beside, I present a handful of examples that illustrate the diversity of nonlinear regression model. Keep in mind that each function can fit a variety of shapes, and there are many nonlinear functions. Also notice how nonlinear regression equations are not comprised of only addition and multiplication. In the table, theta dependent, which is given on the y-axis, are the parameters, and x are the independent variable. As you are observing here, this power of x theta, or given equation theta multiplied with x theta power of theta with 2 is going to be a nonlinear interpretation. The nonlinear model that can be expressed in linear form can be estimated, but least square in linear form require data transformation. As observing here, the curvilinear model relationship is illustrated. All are nonlinear. The x and y, as you observing, either convex or there is a somehow decreasing amount or increasing amount of decrease between y and x is interpreted on the graphics. And when you are going to look this logarithmic transformation on the graphic, you are observing there is also again another nonlinear presentation, whereas beta 1 is for the equation is higher than 0, and for the blue line is lower than 0. When it is lower than 0, there is a decreasing amount of increase between x and y. And when you are looking to the beta 1, there is a increasing amount of decrease between x and y, where x is increasing and y is decreasing as much as you are enlarging and increasing the y. Therefore, this relationship is affecting the so-called the coefficients, or the slope is affecting and changing this relationship between the parameters. The square root transformation is also illustrated here. Similarly, as I mentioned to you, there is an inverse relationship between y and x on the blue line, and for the yellow one, there is an increasing amount of x and decreasing amount of y on the relationship because of the slope. And reciprocal transformation is also given here, which is a U shape, is illustrated, and it is intersecting each other. There is asymptotes here again. And the exponential transformation is also illustrated here. As you see, again, beta 1 is higher than 0, and beta 1 for the blue one is lower. That was the presentation. I go very fast because it was around 100 pages. I hope you satisfied with this quick and faster presentation. If you have any question or any suggestion or anything else, I'm here.
Hocam,
Yes, please.
will you put any link for downloading e-views?
This, you mean this presentation?
No, I am talking about e-views program.
EView program is not downloadable. It is. I bought from shop, and I brought my laptop, and they install it. I don't know if there is anybody who's going to download it from the internet. There isn't, I think. I used EView 10. Next week I will introduce you this on the EView, but I don't have it on the link. I cannot give because there isn't any. I don't know why.
But
Actually, I'm not an expert.
We should find e-views program, I think.
Yes, because we will use EView.
Okay.
If you don't,
okay, sir.
if you don't, then no problem. I will introduce you. Then you will get this video and learn it and perform it. But in the
Okay, sir.
end of the day, you will use this, so you will learn it.
Okay.
You are understanding?
Yeah.
Do you have any? And I think you have to upload this video once again. You have to repeat this presentation some few times for being able to understand this OLS. Because if you don't, then you will not understand the way how you are going to perform this OLS or regression. Because there are some assumptions and some other performance that you have to carefully do. Yes, please.
Hocam,
Sir,
for
if
the
it's-
e-views.
Uh,
Go ahead.
Yes.
You can go.
Okay.
Yes,
Thank you,
Hüseyin
Zuhra.
Hocam.
Hocam, for the e-views, I know it's for sale and it's not findable from the internet. But
Yes.
as I heard, there are some cracked versions. So if I'm
I
looking
don't
for our
Wait,
IT
wait.
to find one, but I
Yeah.
still couldn't one. And the other thing, Hocam, we still need the slides too, except the presentation, because it says how much it should be
Okay,
the R
I will
value. and-
upload. Look, I will upload the presentation and I will upload the video both together, and I will give you the link also for the YouTube. Then you can use any, because if sometimes you are not able to watch when you don't have the access, or when you want to access, sometimes it is not allowed. I will give you all the facilities, then you will then do this. Don't worry.
Thank
Okay.
you, Hocam.
Ali,
you-
sir, sorry, okay.
Yes,
Can
please.
Ali, sir, if it's possible, I will help you tomorrow. The eView student version, that's a free that you can download it so easily. Every student can download it easily. I will help you in that issue. And also, sir, if it's possible, you can upload the presentation in a queue through Microsoft Team. That will be so easy. We can understand if we cannot able to download the video.
Okay.
Okay.
But you can watch the video also, no problem. I will put the PowerPoint also both together, then you will use. Okay. If you don't
Okay,
have any
sir.
question, then next week I will do, as I said to you, I will introduce you how to do, how to upload the data to eView. I will open eView, upload the data, then I will use some unit roots, simple. Then I will do one simple regression analysis for you, and then you will see. And after then, or next week, I may introduce you the unit root also. And then after this unit root presentation, I will then go to the YouTube, eView. Okay, is that okay?
Hocam,
Yes, please.
I always use Stata. We cannot use Stata in this course.
I don't know, but you can use, but I prefer eView. I don't know. You can do it with startup. It's no problem.
So I should learn
think
eViews.
no. I don't force anybody to use eView, but eView for the economics professors, for the economics people. I prefer. I used eView. Stata is not so comprehensively. Stata is somehow. eView is more comprehensive and you are using many things altogether. I don't know. It's my opinion. You can use Stara. I don't force you, but I will introduce you. But in the exam or in the let's say test that we are doing online, you can use Stata. No problem. If you use Stata, you can use Stata, and estimation you will do with this Stata and send me then your results with that program. No problem.
Thank you, sir.
It's up to you. I don't force anybody. Okay, then next week then I will do the unit root, and then after I will go to eView application. I will introduce you the, as I said to you, unit root, data upload, how to upload the data, how you get this first differentiation. You're gonna do the I0, I1 data estimations to see whether it is possible to employ the regression, and then go to the analyze. After this, then you will then do online. Okay, I will let you to do so 15 minutes each to see for two variables, let's say simple regression analyzes, you will upload and do for me. You understand? Then I will give you some 40 points from this. And then going further, I may request some assignment, something as I don't know. It's up to you what you are expecting from me. We will determine, but we will then go through to the tests also. If you want, you can do this performance online, or you will, because there will be no written exam. Maybe in the final, I will give you some written exam. Then we will see how we are going to manage it. This is somehow will be determined later. Okay. If you don't have any question, then wish you nice.
Okay, sir. Thank you so much.
Thank you, sir.
Okay.
Good night.
Good night.